All right, ladies and gentlemen, so the last thing that we had stopped at was we were at the end of Mars and we were just about to start with asteroids. Okay, so asteroids, we know the asteroid belt, or majority of the asteroids, are going to lie between Mars and Jupiter. Okay, when you are looking at them, you're going to realize that the total mass of all of those asteroids, okay, is actually less than our moon. Whenever they refer to the moon, they're referring to the Earth's moon, okay? So the entire mass of all of the asteroids is going to be less than that of the moon itself, okay? There are asteroids that are not in the asteroid belt. Okay, just understand that there are asteroids outside of the asteroid belt. They are not just all there. And those are the ones that we have to be careful with, because those are the ones that are flying through space and are randomly coming towards us, right? The way that they come towards us is they get pulled in by gravity of one of the other planets. They come through, so on and so forth. Hopefully nothing happens, okay? Now, in this picture, you can see an asteroid. This asteroid is not round in any way, shape, or form. Okay, so asteroids themselves are rocky objects that have round or irregular shapes. And a lot of those irregular shapes are because of the fact that they've been around for so long and they've been knocked into and chunks have been taken off and created other parts of the asteroid belt. You notice that there's also craters on here. Okay, and those craters are because of the fact it has no atmosphere, because they're not a planet. So planets mostly have atmospheres, but they have nothing to protect it from the other pieces of dust or asteroids or space stuff that's flying around that potentially can hit into them. Right? Now, here we have the picture that you've seen several times before, right, of all the planets moving in their orbits. Right, you see Mercury over here is flying around the sun, right, and then Pluto and Neptune are super far away and moving super slow. So the asteroid belt is between Mars and Jupiter. We've talked about this before, okay? Most of the asteroids that we know of are in between Mars and Jupiter. They're part of this. Now, I've told you before that the scientists do believe that this is a planet that just never formed. Okay, during when our solar system was created. Okay, so they believe that this is a planet that never formed, which means that it never really knocked into each other enough to start rotating, which means it didn't coalesce, which means that it didn't create gravity, which means that it didn't get more denser, so on and so forth, right? Asteroids themselves are going to range in size from a tiny little piece of dust to almost the size of our moon. Okay, so they could be very tiny or they could be very large. If we have a moon-sized asteroid, hopefully it stays away from us and will not come in contact with us. And you're going to find out why, what happens. Okay, most of the asteroids that you see pictures of are photographed by what's known as the Galileo Probe. Okay, it's just a scientist. You guys all know Galileo at this point, or at least you have heard of him, okay? And they named the probe because he probably had a prototype that actually worked a little bit. So these asteroids that I'm going to give you, you are required to know their names and their sizes, if they have sizes with them, okay? These are the ones that the Regents likes to throw at you, and you have to know that they are classified as an asteroid. It's kind of like if I throw out the word Mercury, you have to know that's a planet. If I say Halley's Comet, you have to know what it is, and you're responsible for knowing what a comet is also. So they love to throw these specific ones out, like Ceres. Ceres is the largest known asteroid at a diameter of 940 kilometers. Okay, that's the number one. Okay, then there's Pallas. Okay, it's 523 kilometers in diameter. Then there's Vesta. Vesta is 501 kilometers. So we're getting lower as it goes on, but these are the named asteroids that you need to know. Then there is Juno. Juno is 244 kilometers. And finally, there's Gaspra and Ida. These are all different types of named asteroids. Okay? When you guys take the regions, I know you guys didn't take one last year, which kind of stinks because you didn't get to actually see what it's like. They like to put current events on there. So the things like if we send a satellite to go investigate an asteroid, they might put that on there. Let's say they put it on and said, a satellite was going to visit Ceres this June. You know, explain why seeing Ceres would be important. You know what I mean? So it's like current events, sort of, kind of, maybe, that you're going to have to know that Ceres was an asteroid. You're going to have to know that it's the largest one. If there's any history behind it, usually that's part of the reading. But that's the kind of stuff that they want you to know. Okay?
Ms. Gonzalez?
What's that?
Why is there no measurement for Gaspra and Ida?
Because you don't really, it's less than 244, and it's not that big, but you just need to know the names.
Okay, thank you.
No problem. So, the same way that the planets were formed is how the asteroid belt was formed as well, right? You had a bunch of space stuff, right? And you had this supernova that happened. Guys, do you remember how many years ago that the solar system formed?
4.6 billion?
Yeah, 4.6 billion. Very good. Okay, so that's one of the numbers that you need to know for this unit as well. Okay, so that supernova happened and it pushes everything close together and they start to spin. When they spin, they start to flatten. When they flatten, the center starts to get hotter and hotter and hotter and hotter and hotter until, bam, we had a nuclear process known as what?
Nuclear fusion.
Fusion, good. You don't have to say nuclear fusion, you can, but if I say a nuclear process, you can just say the word fusion or nuclear fusion. Totally up to you. Okay? And then all of a sudden, the energy pushed everything out, and then the stuff that's around the sun started to coalesce and started to pull in, and ta-da, we get our solar system and the asteroid belt. That's why they think that the asteroid belt is a planet that just never formed. Okay? Because it's made up of the same stuff that the other planets are as well. Okay? So in this little video here, you want to see it. It's kind of cool. It's a home video. It's quick. Of an asteroid making impact with the Earth. Watch back here. There it is. Whoa. That's what was left. So what you were seeing there is as the asteroid came into our atmosphere, you saw how it blew up. It wasn't blowing up, it was actually heating up. And that bright glow was because it was moving so fast through our atmosphere that it was trying to, it was heating it up and heating it up and heating up. This second video is what would happen if we had a large moon-sized, there's no sound to it, so I could talk over it. But this is a large moon-sized asteroid, right? You can see it has craters. What would happen if it hit the Earth? So the whole thing is that these asteroids are in their own orbit. If one gets knocked towards us, now look at the size of that. It is way smaller than our planet, right? All right. It gets pulled into our gravitational pull, right? And it has no other choice but to hit us. So what happens if it hits us?
Earth is destroyed, probably.
Well, let's watch. All right? It's not a very, very large, but it is considered to be a large asteroid. In comparison to us, it's not that large. Okay, it heats up and then kaboom, it hits into us, right? Oh no. Right? That is the worst tsunami ever, because that's pretty much what it just created, was a tsunami or a giant wave. Okay, but because it hits the earth, not only the water, but it hits the crust and the mantle, it kicks up all of the extra stuff like land and fire and lava and everything that's underneath it. So if this is what scientists are afraid of, is basically a total catastrophic event with no survivors, is pretty much what would happen. So of course this is a computer simulation. Okay, so this is the leftover stuff that was thrown into the air and it's now coming back down. So if the impact didn't kill you, then the random chunks of molten rock are going to kill you, or the lava that it exposed is going to kill you. Right? This is the crater that one meteor basically created, but it's a ripple effect if you think about it, right? Even though that crater has stopped getting bigger, it's forcing all of that energy and all of that rock and water and lava in every direction. It's one way to get rid of snow. Right? This is what would happen on Earth itself. And it all really depends on how close you would be to the meteor impact. If you're further away from it, then it might take you a little bit longer to die, but eventually you would die. There's really no escaping this if, God forbid, this happened. Okay? It's crazy to think about. Right? There's Big Ben. Right? So this is like I said, a total catastrophic event. Right? There are basically no survivors. And notice, it creates a cloud around the Earth of all of that stuff that got kicked up. It's crazy, right?
Yeah, it's very crazy.
Right, there's South America. Right? And there's Australia. And that's where the original impact was. Notice how much smaller that is than the Earth itself, but it's a catastrophic event. Okay? If you really want to watch this video later, you can. Veritas Aaron is one of those people I love watching because he is great and he explains everything phenomenally. Okay, so let's go back to the asteroid belt now that everybody is thoroughly depressed. Okay, so it's a belt between Mars and Jupiter. We already know this, right? Here's the part that you don't know yet. It's going to contain several million asteroids, okay? And they're going to range from the size of a speck of dust through 100 kilometers in diameter, okay? So they are all over the place. But about 1 million of them are about 1 kilometer or 0.6 miles or bigger. So out of the several million, let's say there's 5 million. Okay, I don't think anybody really went and counted how many there are. At least 1 million of them are pretty large. Okay, and that's something to worry about in the long run.
Well, I mean, we're not going to be here in the long run. So I mean, I'm feeling kind of cool.
Well, you never know. You never know.
That's true. That's true.
Okay, so here's a picture, a satellite picture of the asteroid belt. So notice the size differences, right? You have some that are small, some that are large. Oh, you're the best. Thank you. Oh, good. Thank you. Okay, so just by looking at them, right, you can see they all range in different sizes. Okay. So there are three ways of actually categorizing asteroids, right? And it's dependent on what they're made up of, their color, and how much they reflect the light. Okay.
I have a question.
Sure.
So, you know how we have to know some of like the asteroids' names and stuff?
Mm-hmm.
Why do they pick those specific asteroids since there's so many other asteroids? Like, why do they pick those specific ones to name?
I think, to be honest with you, like Ceres, they picked because it's the largest one. I'm not really sure why they picked the other ones, other than I think those are the ones that they've been researching over the years and keeping an eye on. That's my guess with it. But those are, I mean, Ceres I've seen come up in the regions before, and they'll say, they'll ask you a specific question on it, and Ceres could be one of the answers. And you just have to know, like, the answer might not have anything to do with it. It might be like, which of the following is one of the foci for a planet, and Ceres might be there. But you want to make sure that you know that Ceres is an asteroid, and asteroid probably is not one of the foci. You know what I mean? But those are the ones that I've seen them pick before. So I have a feeling if you research them, those are the ones that they actually have been keeping an eye on. Like NASA has been keeping an eye on them for whatever reason. They've just been researching them. You know, and then there's also the asteroid that was around during the during the start of the solar system. Remember the video we watched? I can't remember his name right now, but that they are starting to keep an eye on more and to research more and sending a satellite over to them.
Thank you.
No problem. So there are three different types of asteroids. There's type C, type S, and type M. Type C, you have large amounts of carbon and silica. Okay, they're very dark in color, and so they're going to reflect very little light. This is about 75% of all asteroids. All right. There's type S, which is a mix of nickel and iron with silica, okay, and magnesium. So it's a relatively bright asteroid, and that's about 17%. The other percentage is type M, which is just pure nickel and iron. So they are very, 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 very bright. Okay. I'm not going to ask you to classify them. I'm just telling you that these are the three that you need to know. Okay.
So Miss Gonzalez, we've
What's
all
up?
seen the movies, right? We all seen those extinction movies. Like, are there ways that we could actually take if an asteroid that size were to come to Earth, or precautions, I
Um,
should say?
to be honest, I hope we're never in that situation to figure it out. And, you know, Bruce Willis has to dig a hole into an asteroid to make sure that he saves Earth. Um, but I don't know. I don't work for NASA, and there's a lot of stuff that they don't tell us right now. So they're probably working on things because we've had a couple of close calls. So they're probably working on things, but I don't, like I said, I don't work for NASA. You know, I wouldn't be here if I worked for NASA. All right, so they're probably working on something, if I had to guess. It's probably not high up on their priority list, probably like below colonizing Mars, but enough that they're saying, hey, by the way, there's a couple asteroids that came pretty close to Earth. We might want to work on how to deflect it just in case. All right, so here are just some pictures of some asteroids, right? Very nice. Notice that it has craters, right? Because it doesn't have anything protecting it. It has no outer layer protecting it, so it's going to get hit by other stuff. Okay? Right, here's just some more pictures. Ugh, that one's just rocky and nasty looking. Okay? All right, so I'm going to move on to comets. Now, comets, I want you to highlight, to star, to underline, to draw a Christmas tree, whatever it is, to make you understand that it's important. Okay? The Regents Board loves to talk about comets and to ask you guys questions on comets. I've already given you a couple. I've given you Halley's Comet when we were talking about the orbits, right? And I said, why is, I could ask you about the eccentricity. I could ask you about how far the foci were, right? That question showed up a couple of times between your homework, your test, and your quizzes, right? It showed up a couple of times just in different forms. So there's a lot you can ask about a comet. And the Regents Board is obsessed with comets. It shows up in the last 5 years. It has shown up for at least one question every region. At least one question. Now, one question could be 4 parts, right? So comets are more affectionately known as dirty little snowballs, because they are, okay? They are basically made out of frozen material with dust and space stuff that makes them dirty. All right. Comets are only going to be visible when they are close to the sun. All right. They're not going to be visible to us when they are really far away because it's reflecting the light off of them. And because we'll learn later, remember the sun is a star. Keep that in mind for a sec. All right. So basically, a comet has an icy nucleus. It's like the head. It's like a tadpole. If you've ever seen a tadpole, right, before it sprouts the legs, right, it looks like a little worm, right? It's got a head and then a tail, okay? That head is an icy nucleus, okay? As it gets closer to the sun or to a star, which is large and full of heat, okay, it will start to melt and it'll create that tail, okay? Comets have a highly elliptical orbit, which you already know because you've seen questions on this already, okay? They will occasionally come closer to our sun, and we will see them. Notice that the head of the comet is always pointing towards the star, okay? The tail is always going to face away from the star. That is very, 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 very important. You think it's important? Okay, so when it goes in its orbit, the nucleus or the head will always face towards the sun, okay? And if you think about it, it makes sense because as the head actually evaporates, it creates the tail. So if the head is pointing any which way but towards the sun, then the tail isn't going to form correctly. All right, so let's talk about its composition. All right, it is made up of dust, which makes it dirty, rock, which makes it dirty, frozen methane, ammonia, and water. Now, those three things have basically started since the beginning of time. Okay, if you go to the Museum of Natural History, obviously not right now because we're in the middle of the pandemic and yay, when you can, go. And you go to the top part of the astronomy, like you walk into this big white room, and if you go all the way up, there's a stair, like a little, not a staircase, but it's just like a ramp that comes down in a spiral. If you look up, there are actually 3 molecules that are created up there. One is black with 4 white things attached to it, okay? One is blue with 3 white things attached to it, and one is red with 2 white things attached to it. That's methane, ammonia, and water, okay? Because they play a large part at the beginning of everything, okay? You are responsible for knowing their chemical formulas. Now, these numbers are actually little subscripts. They should be down here, but unfortunately, you cannot do that on PowerPoint. So it's got to be like a little, it goes capital C, capital H, little itty bitty 4. Okay? So, like I said before, comets are going to look like dirty snowballs, right? When they get too close to the stars, now this is what I was saying before, they start to change. Why? Because stars are very, very, very hot. If you take ice and you put it by a flame, what starts to happen?
It starts to melt.
Right. So it's the same thing here. But the difference is that when it melts or it vaporizes, it starts to glow because you're heating it up so quickly. It starts to glow. All right. And that's when that tail or that coma starts to form. Right. And all the tail is melted parts of the nucleus or the head. Right. So the coma is going to be a glowing trail of the nucleus particles. Okay. Again, it always points away from the star. Okay. Eventually, if the comet doesn't refreeze into its original shape, it will completely break up and create more space debris. Okay. Now, there's this thing known as an Oort cloud. It's kind of a fun name to say, Oort. Okay. Basically, outside of Pluto, there is a large collection of comets. And if you think about it, it makes sense. Pluto would have been our coldest planet because it's the furthest away from the sun if it was still considered a planet. It's not, it's a dwarf planet, right? So if you have comets, which are basically clouds of ice, right? Where are they going to hang out? They're going to hang out outside or by the coldest place that you can find. So to us, the coldest place that you can find right now is outside of Pluto. You guys good?
Yeah.
Can you wait for like 2 seconds?
Sure. That's why I asked.
Okay, thank you.
No problem. Okay, some pretty pictures. All right. Okay, so let's see if this works. What? I put the, oh! Ah! Wait, hold on. I just found one. I'm sorry, guys. I literally just found. What? I just found this really great video for you guys to watch. Come on, search. Where'd it go? So sad. Why aren't you searching? See, YouTube loves me, doesn't it? You guys laugh. Technology hates me. No. Was it this one? No, you're quiet. No. Where's my friend? There he is.
Astronomical units away from us. 1 AU.
As you can see, I was watching it. I'll finish this, guys, before you go. Okay? So, we have these things known as meteors, meteoroids, and meteorites. All right? This would be a meteor that hit the Earth. Okay, this is the impact. All right? The thing is that in order for this chunk of rock to hit us, it has to go through the atmosphere. I literally need 3 minutes, guys. It needs to go through the atmosphere, not completely burn up and hit Earth. Okay? That's what this is. The largest meteorite to actually hit Earth is in Africa. That might have been double or triple the size before it hit Earth because it had to get through our atmosphere and burn up. Okay? So basically, guys, you have meteoroids. Meteoroids are chunks of rock that are outside of our atmosphere. Okay? They are randomly moving through space, and they are usually leftover comet or asteroid debris. Okay? So there's meteoroids, meteors, and then meteorites. Okay? Meteoroids are, like I said, they're outside of our atmosphere. They are chunks of rock that are floating around. Okay? They're randomly moving. Okay? So they could be leftover of that comet that broke down and became space debris, or it could be leftover an asteroid that banged into each other and it just had nowhere to go. Okay? So that's a meteoroid. Then you have a meteor. A meteor is a meteoroid that actually comes into our atmosphere. Okay? That's what you know as a shooting star. Stars are not randomly shooting through our atmosphere. Okay? That is a meteor that came into our atmosphere. When it comes into our atmosphere, it heats up and it glows. Right? And that's what you see as a shooting star. Now, in order to stay classified as a meteor, it has to burn off before it hits us. So if it comes down and it touches the surface of the Earth, then it is no longer considered a meteor. Okay? A meteor is one that comes into our atmosphere and just completely burns up, not a danger to us in any way, shape, or form. Okay? Meteorite. A meteorite means that it hits the surface. Okay? It creates an impact crater. Okay? And those are the three, guys. Once you get this, you're good to go. Have a great weekend. I told you it would only take me 3 extra minutes. Okay, but know the difference between a meteoroid, which is outside, meteor, which is a shooting star, and meteorite, which creates an impact crater, right? That's how we get some of our craters. But remember, we don't have a ton of them because of the fact that we have that thick atmosphere. All right, guys?
Have a good day.
Bye.
Have a great weekend. Enjoy.
I have a question about the project really quick.
Give me 1 second to stop.
Bye.